And here we go.
10.
Hydrogen burn-off igniters initiate. 7, 6, 5. 4-stage engine start.
On June 9, 2026, NASA announced the crew of Artemis 3. 4 astronauts, a commander with 2 space flights and a Top Gun certificate, a European Space Agency pilot who once commanded the International Space Station, a physician who spent 371 consecutive days in orbit, the longest any American has ever been in space, and a first-time flyer, an engineer who designed robotics for deep space before becoming an astronaut. The names are Randy Bresnik, Luca Parmitano, Frank Rubio, and Andre Douglas. They will fly to space in late 2027. They will not land on the moon. That last sentence is the story.
What I believe history will record.
For most of its life, Artemis 3 was presented as the mission, the return. Humanity back on the lunar surface for the first time since December 1972, when Apollo 17 commander Gene Cernan climbed into the ascent stage and left footprints that are still there. 50-plus years of absence ended by a crew landing near the South Pole, a location Apollo never reached, in terrain that's never had a human boot in it. The plan had all the hardware figured out, at least on paper. The Space Launch System would lift an Orion capsule to lunar orbit. Waiting in that orbit would be SpaceX's Starship human landing system, a variant of the same rocket Elon Musk is using to think about Mars, adapted to ferry 2 astronauts from lunar orbit to the surface and back. 2 crew members would descend. They'd spend roughly a week on the surface, conducting science in permanently shadowed regions where water ice has been confirmed. Then back up, back into Orion, back to Earth. That was the plan as recently as 2025. Then, February 2026 happened. On February 27, 2026, NASA announced a revised Artemis flight sequence. Artemis 3 was no longer a lunar landing mission. It was redesignated as a crewed demonstration flight in low Earth orbit. 2 weeks in space, no moon, focused entirely on testing the hardware that Artemis 4 will need to actually work. The stated reason? Risk reduction. Before you send humans to the lunar surface aboard a lander that has never been crewed in space, you want to know that the lander's docking systems work, that the life support functions, that the crew can get in, move around, run checkouts, and get back out. You want to run those tests where, if something fails, you can abort to Earth in hours rather than days. Low Earth orbit gives you that. The lunar surface does not. So, Artemis 3 will carry 4 astronauts to Earth orbit aboard Orion on the SLS. Already waiting there, launched separately, will be test articles. NASA is calling them Pathfinders, of Blue Origin's Blue Moon lander and SpaceX's Starship HLS. Not the final flight vehicles. Stripped-down versions missing key systems, built to prove the docking interfaces, the airlocks, the crew transfer corridors actually work in space the way they work in simulations on the ground. The crew will spend about 2 days docked with Blue Origin's test article. They'll enter it, run hardware checkouts, and return to Orion. Then, roughly a day docked with SpaceX's Pathfinder for the same suite of tests. Then, undocking, re-entry, splashdown. Mission complete. Lunar surface? Not part of the itinerary. NASA was careful in how it presented this. Not a failure, a maturation of the plan. The agency described Artemis 3 as essential groundwork for Artemis 4, which remains targeted for 2028 and which, if the hardware holds up, will be the actual lunar landing, the first since Apollo. Randy Bresnik, the commander, flew aboard Space Shuttle Endeavour in 2009 and spent 139 days on the ISS in 2017. Former Marine fighter pilot, Top Gun graduate. At 58, this will be his 3rd spaceflight and his first on SLS Orion. He's the kind of commander you pick when the mission involves flying a spacecraft that has only flown twice with crew aboard. Luca Parmitano, pilot, is an ESA astronaut and Italian Air Force test pilot. He flew 2 long-duration ISS missions in 2013 and 2019 and commanded the station during his second. He's also the astronaut who nearly drowned during an EVA in 2013 when water leaked into his helmet during a spacewalk. He finished the EVA, reported the anomaly calmly, and the spacewalk was terminated safely. The incident led to a redesign of suit water separators. That's the kind of pilot you put at the controls of a spacecraft doing first-of-kind rendezvous operations. Frank Rubio spent 371 days on the ISS from 2022 to 2023, returning on a Soyuz after his original capsule was damaged by a micrometeorite strike and deemed unsafe for re-entry. His extended stay, 193 days beyond the original plan, broke the American duration record. He's a physician and Army veteran. His first spaceflight lasted longer than any Americans in history. His second will last 2 weeks. Andre Douglas is making his spaceflight debut. He worked at the Johns Hopkins Applied Physics Laboratory before joining NASA's 2022 astronaut class. Engineer background, deep space robotics experience. If Artemis eventually puts humans in the vicinity of systems that require robotic operation near the lunar surface, that expertise will matter. Bob Hines trains as backup for the crew. He flew to the ISS in 2022 as pilot of Crew Dragon Freedom. The Artemis 3 redesign is frustrating if you're tracking the moon return timeline. But from the perspective of anyone thinking seriously about long-term lunar presence, it's the correct call. And the reasoning is straightforward. The south pole of the moon is not forgiving terrain. Permanently shadowed craters at temperatures below -160 Celsius, perpetual darkness in the crater floors, highly irregular surface that hasn't been mapped at the resolution you'd want before landing humans on it. The landers going there, Starship, HLS, and Blue Moon, are the most complex crewed vehicles built since Apollo. And unlike Apollo, they've never carried a human being in space. 0 flight heritage with crew aboard. A 2-week mission in low Earth orbit that fully validates the docking interfaces and crew systems before those vehicles go to the moon isn't delay for delay's sake. It's the difference between landing on the South Pole with confidence in your ascent system and landing with untested hardware between you and the return trip. The Apollo program lost 3 astronauts in a ground test. Moving carefully on hardware that hasn't flown with people is not overcaution. It's the lesson the program was taught, at the cost of 3 lives in 1967. For anyone thinking about what permanent lunar infrastructure eventually looks like, habitats, resource extraction, surface power systems, the real question isn't whether Artemis 3 lands, it's whether the commercial landers work. Blue Moon and Starship HLS are not just transportation for 4 missions. They're the architecture everything else is built on top of. Validating them before betting lives on them at 384,000 kilometers from the nearest hospital is exactly right. Artemis 4 is the mission the redesign is building toward. NASA is targeting early 2028. 2 astronauts will descend to the lunar South Pole and spend approximately a week on the surface, the first humans there since 1972. The landing site will be one of 9 candidate regions identified near the South Pole, all chosen partly for proximity to confirmed water ice deposits. Water ice is the resource that changes everything. At the South Pole, in permanently shadowed craters, ice has been accumulating for billions of years, delivered by comets, retained by the permanent cold. If you can extract it and electrolyze it, you have hydrogen and oxygen, rocket propellant, breathable air, drinking water, an in-situ resource that eliminates the most expensive part of any sustained lunar presence, the cost of shipping consumables from Earth. NASA has 9 candidate landing regions for Artemis 4. Each one was evaluated for terrain, accessibility, communication line of sight with Earth, and proximity to ice. The final selection hasn't been announced as of June 2026. Starship, HLS, and Blue Moon are competing for the contract,
with one or both potentially carrying crew to the surface on different missions. The European Space Agency's Gateway, a small space station in lunar orbit, is also part of the longer-term architecture. Artemis missions from 4 onward will eventually incorporate it as a waypoint and crew habitat in lunar orbit. The first Gateway module, HALO, is targeted for launch in 2027 on a SpaceX Falcon Heavy. 3 things that determine whether this timeline holds. First, the landers. As of mid-2026, neither Starship HLS nor Blue Moon has completed an uncrewed lunar landing demonstration. Starship has conducted integrated flight tests from Earth, but has not landed on the Moon. Blue Moon's development is less publicly visible. Both vehicles need to demonstrate lunar landing capability before crew boards them for Artemis 4. Whether that happens on a schedule compatible with a 2028 crewed landing is the central uncertainty. Second, SLS production. Artemis 2 flew in late 2025 as a crewed lunar flyby, the first humans to leave low Earth orbit since Apollo 17. The Artemis 3 SLS core stage and mobile launcher are in preparation at Kennedy Space Center, targeting late 2027. Manufacturing and assembly timelines on SLS have historically slipped. Late 2027 is achievable, but not guaranteed. Third, cost. Mars sample return got paused because $11 billion for one mission was deemed unaffordable. Artemis isn't cheap. Estimates for the full program through Artemis 4 run well past $90 billion across NASA, ESA, and commercial partners. How much of that holds through a budget cycle and a half is a political question as much as an engineering one.
Artemis 3 is not the moon landing mission anymore. It's the mission that makes the moon landing mission possible. That's a distinction worth understanding, because the plan, if it holds, still ends with humans at the lunar South Pole for the first time in history, standing in terrain that Apollo never reached, sampling ice that formed before the Earth had continents. The crew was announced 3 days ago. 4 people training right now for a mission that will test whether 2 competing commercial spacecraft can rendezvous, dock, and support crew in orbit, so that Artemis 4 doesn't have to find out those answers at 384,000 kilometers from home. 1 mission, 2 landers to test, 1 moon to reach. 2027.